All right, so I just wanted to do a quick reminder on complex numbers and imaginary numbers and how to deal with them. So, talking about all the different pieces that we've talked about in class. First thing I want to start with is the simplifying piece of it. Now, I'm going to take this a little bit farther than what we did in class just so you can get a better idea of where we're headed with it. So, what you had learned was that anytime you take the square root of a negative number, that gives you what we call an imaginary number, which is kind of an unfortunate name, but it's fine. So, how we split that out first is we split out the -1 from the rest of the number, meaning we're taking these two things and multiplying them together to make the original number. So -1 times 100 would give me -100. Now, anytime you take this piece out, that automatically becomes an I. And then I treat the positive piece as though it never had this negative piece in it. So I can take the square root of 100 and get 10. So in this case, our answer is, if you stick those two pieces back together again, the plus or minus 10i. This would give us the square root, or the simplified square root of an imaginary number. What about if the number isn't perfect and it doesn't take a square root nicely? Well, we would still split it out into its two pieces, so -1 and the square root of 32. Now, what we talked about in class was that you would leave this as just an I, and you would just leave this as 32, so it would become I squared of 32. But that's not really as far as you should be taking it. Now, using an idea you learned back in Algebra 1, we're going to simplify this square root, which basically says you take this number and you see if it's divisible by any perfect squares. So numbers such as 4, 9, 16, 25, 36, so on and so forth. So, off of that list, 32 is divisible by 16. In fact, it's 16 times 2. But what's the square root of 16? If you said 4, you'd be exactly right. So we're going to bring that down, 4. So we have I times 4 times the square root of 2. Or if we want to write that nicer, 4i square roots of 2. That would be where that complex idea comes from, that has multiple pieces to it. So I'm going to show you that again. Split it out into two pieces. Now the -1 becomes an I, that we know. But if we focus on this positive piece, we say, which one of the numbers on our perfect squares list is 72 divisible by? It's divisible by multiple of them, but it's divisible, the largest one, is 36. Square root of 36 is 6. So we have 6 times I times the square root of 2, which would be rewritten as 6i square roots of 2. I've had a lot of you ask me if I can put the I at the end of the number, and you can. The problem is that if you put it at the end, so if we were to rewrite this as 4 square roots of 2i, it's hard to tell if that I is under the square root or not under the square root. So if you're going to do it this way, you need to be conscious about showing that that square root ends after the 2 and that the I is separate. So it's a little like garage door is how we do that. You won't usually see me write it that way, just because this is kind of the more generally accepted form, where you put your number followed by an I if you need it, followed by the square root. It's just generally the order we write it in. Now, we talked about lots of different pieces with square root, or with imaginary numbers. So I'm going to look at adding and subtracting options too, just to show you what those look like. So when we're adding or subtracting, it doesn't really matter. What you're going to do is combine your like terms. Meaning, all the I pieces get combined, and all the not I pieces get combined. So in this case, I have a 5, and I have a 2. Those are the only pieces that don't have I's. So I have 5 plus 2, which would be 7. Then I've got 6i, 3i, -4i. So 6 plus 3 plus -4. 6 plus 3 is 9, plus -4 would be 5i. Now with negative numbers, you have to be really careful about watching that sign in between. So if I'm looking at my real pieces, I have 4. This negative gets distributed into both pieces, so this would be a -2. And then same thing here. This would be a -4. So I have 4 minus 2 minus 4, which would be negative 2. Then I've got 8i minus negative 3i, which would become a positive 3i, and a negative 5i. So 8 plus 3 minus 5, which would be 6i. So like I said, you have to be careful to watch those signs in between. The way I do it, when I think about it in my head, is as though this is like a little trampoline for you to jump on. So when I do this, I go 8 minus negative 3 minus 5. So the minus and negative becomes 8 plus 3 minus 5, which is exactly what we did up here before. So adding and subtracting is just straight up combining like terms. That's all it is. It's multiplying that becomes a little bit more complicated. Now, I prefer to do this using the box method. If you're somebody who prefers FOIL, you can absolutely do that also. But how we set it up is we put our two parentheses on the outsides of the box, and you multiply in. So 3 times 6 would be 18. 3 times 2 would give us 6i. Negative 5i times 6 would give us negative 30i. And the bottom corner would be negative 5i times 2i, which is negative 10i squared. Now, in your research, you learned that I squared is actually a negative 1. So this is actually negative 10 times negative 1, or positive 10. So if I wanted to write out my solution, it would be 18 plus 6i minus 30i plus 10, which then I can combine my like terms, my non-I pieces and my I pieces. Technically, if you write out your solution with an I squared in it, it is not simplified. You do need to figure out what that piece would become. So it's changing this from here into there and then combining your like terms. One more time. So 10, 3i, 2, 4i. It doesn't matter which parenthesis goes on each side. Multiply. So 2 times 10 is 20. 2 times 3i is 6i. 4i times 10 is 40i. 3i times 4i is 12i squared. Now, I squared is negative 1, so this is 12 times negative 1, or negative 12. So my solution, 20 plus 6i plus 40i minus 12. Combine my non-I pieces, combine my I pieces, and I get this as a solution. So if you're making notes to yourself, adding and subtracting is straight up combine like terms. So you're going to combine your common terms. Up here, this is simplifying, so you split it out into two pieces, and then you simplify the positive piece if you can. Multiplying, I prefer the box method. If you prefer FOIL, that's fine. And you have to remember to simplify the I squared box. Just some notes to yourself in case you're struggling with this.